Bismillah ar-Rahman ar-Rahim. This is a short exercise about sequences. So let U index n be a numerical sequence. Show that the subsequences U index 2n and U index 2n plus 1, which means that the odd and even natural number and U index 3n are convergent if and only if UN is convergent. This means that if UN is convergent sequences, all the subsequences are convergent, and conversely, if the three subsequences are convergent, this must implies that the sequence UN is also convergent. The second question, if UN is an increasing sequence and U2n is convergent subsequence from this one, prove that the sequence U index n is convergent. So here we don't suppose that UN is convergent. We have just two informations. The first information is that the sequence UN is increasing. We can do the same thing with decreasing. And we suppose that the subsequences U index 2n, and we can take any given subsequences, so we are not obliged to take only to n, but we can take n index k, which means that for all subsequences this statement is true. Let us start with the solution. A given solution, for sure there is other ways to carry on the solution. So for the first question, if the sequence is convergent to a limit L, then all subsequences is convergent and it converges to the same limit. This is because it is a special case, so we can this is also true. Conversely, we suppose that U index 2n, U index 2n plus 1, and U index 3n are convergent. Here we should remark the following indication. We can remark that U index 6n is a subsequence from the subsequence U index 2n and U index 3n. If here we take n 3n n prime, we will get U 2.3n prime, which is U 6n prime. And since n and n prime are the same thing, so we take U6n. And for U3n, if we take n equal to 2n prime, we do the same thing, and for sure this subsequences is a subsequence from this one and this one. This means what? This means that this subsequence and this one have the same limit. Very important. And can I say very smart. So the idea is smart and not me. So for the second half, we can also remark that U index 6n plus 3 is a common subsequences of U 2n plus 1 and u3n. If we understand this idea, this means that what? This means that the sequences, since it is a subsequences of this one and a subsequences of this one, this means that both of them, this one and this one, have the same limit. But u3n and u2n plus 1 have the same limit, and u3n and u2n have the same limit. In conclusion, u2n and u2n plus 1 have the same limit. This is the conclusion. We finish, it's all. So, if the limit of u to n is equal to L, because they have the same limit, and this L is the same as this one, so by definition, epsilon n1 definition, for any given positive epsilon, we can find a rank n1 such that after the rank, the difference between the terms, the nth term and the limit are less than epsilon. We have the same thing with u index to n plus 1. They have the same limit. Sorry. So what we can deduce? We can deduce that actually the limit of un is equal to L. Why? This is true because for any given epsilon positive, we can find a rank. The rank is equal to the maximum between 2 and 1, this one, and the 2 and 2 plus 1 and 2 is this one, such that after the rank n, un minus L is less than epsilon. Why? Because if n is even and greater than 2 and 1, this ensures that the difference is less than epsilon. If it is odd, this means that n is greater than 2 and 2 plus 1, which ensures that the difference is less than epsilon. And we finish the first question. For the second question, if un is an increasing sequence and u to n is convergent, then the sequence is convergent. We have u index to n is a convergent. This means that for any given epsilon positive, there exists a rank such that after the rank, we have the difference between un and L are less than epsilon. We can reformulate this inequality as follow, because we need it in a sense. So the limit of un is equal to n. This means that for a given n0, the same, and for all n greater than n0, we can write this L plus L minus epsilon, sorry, L minus here, here minus epsilon, and here we have just n and not 2n. We have just n and not 2n. But if we take un is an increasing, so for any given m greater than n0, there exists n greater than n0, such that for all m which is greater than n0, we have u index m is greater than u index n0. Why? Because we have the limit of the sequence u index to n is equal to L. And for this, we find we found a rank such that it is true. Remember here we have minus. And since the sequence, the subsequence are increasing, so we can find n such that u index m is less than u index to n. But this means that our subsequences is convergent. This is a given assumption. So from this one, we can conclude that for any given m greater than n0, we have u index m minus l is less than epsilon. And this means exactly that the subsequences, the sequence un is a convergent one. This is all. Thank you. See you next time.